What is the parameter of p, or the effective parameter p on the graph? The p-value moves the graph left and right. Compared to the graph of y is equal to x squared, the graph of y is equal to x minus p squared results in a horizontal translation of p units. So from this point on, we're always going to specify, we're not just going to say translation, we're going to say it's either a vertical translation, which is going to be affected by q, or a horizontal translation, which is going to be affected by p. If p is greater than 0, then it's going to move to the right. If p is less than 0, it's going to move to the left. The only thing you have to be careful of is, because it is x minus p, if I had x minus 3, the value of p is positive 3. If I had x plus 3, because it is x minus p, that would actually be the same as x minus negative 3. And p is actually a negative there. So remember that if it's inside the brackets, it's always going to be the opposite of what the sign is the actual value of p. The last variable we have to look at is the coefficient of x squared, or when I have a p-value, what's going to be outside of the brackets. This is my a value. So if I'm writing an equation that represents each of the following, if I have y is equal to 2 f of x, that would be the same as y is equal to 2x squareds. If I have y is equal to negative 2 f of x, that would be y is equal to negative 2x squared. And in the last case, if I have y is equal to 1/2 of f of x, it is y is equal to 1/2 x squareds. For everything we've done so far, it hasn't changed the shape, but we see right as soon as we put the first one in, the 2x squared, it is changing the shape. Suddenly, I see that I have a vertex at the same point, but my graph has gotten quite a bit skinnier. When I put in the second one, y is equal to negative 2x squared, this is the first time that we've seen where my graph opens downwards. And for the last one, when I put in y is equal to 1/2 of x squared, then suddenly my graph is getting quite a bit wider. So if I'm completing the statements, compared to y is equal to f of x, or the graph of f of x is equal to x squared, the a value of 2 results in a vertical stretch by a factor of 2. When we're talking about a vertical stretch, what we mean is that all of my y values double. if we take a look back at our original graph as compared to the new one, for my original graph, when y was 2, or y was 1, now it's 2. When y was 4, now it's 8. So it's literally doubled the y values. The y coordinate on each point is multiplied by a factor of 2. If I put this in mapping notation, if my original coordinates were x and y, now it's going to be x and 2y. I literally just double every point for y. If I look at the a value of 1/2, then I wind up with a vertical stretch by a factor of 1/2, which means that I'm going to multiply every y value by 1/2, or putting it in mapping notation, is going to go from x and y to x and 1/2 of y. If I look at that case, which was the red one, then suddenly, if it was x was 2, or sorry, y was 2, then it's going to cut in half, which is what gives it that appearance of being considerably wider. And in the last case, compared to the graph of f of x is equal to x squared, the a value of -2 is going to result in a reflection in the x-axis. This also has the value of 2, so it's going to cause a reflection and a stretch. It's not just going to flip downwards, but it's going to elongate when it flips downwards. So this is going to give me a vertical stretch by a factor of -2. The y-coordinate on each point is going to be multiplied by -2. If I'm putting this in mapping notation, then I would say that x, y is now going to become x, and the first thing we do is we make every y value negative. That is going to be that reflection that happens across the x-axis. Then, after I've reflected all the points, that's when I would do the vertical stretch that occurs. In general, when compared to the graph of y is equal to x squared, the graph of y is equal to ax squared results in a vertical stretch by a factor of whatever the a value is. If a is bigger than 1, it undergoes a vertical expansion, which is going to make it look narrower or a little bit skinnier. If it's between 0 and 1, we call that a compression because it's going to make it look wider than it actually is. And if a is less than 0, then we have a reflection over the x-axis, which means that suddenly it's going to go from opening up to opening down. So if I'm completing a chart, if I have y is equal to f of x, then the a value, if it's not written with any coefficient, is just going to be 1. If I had y is equal to negative f of x, that a value would actually be -1, which means that my equation would be y is equal to -x squared. Now, we've seen that with the a values, every single one of them had the exact same vertex because it doesn't move it left, doesn't move it right, doesn't move it up, doesn't move it down, it just changes the shape and direction. So unless we have a P or Q value, the vertex stays the same. Now, it's not going to change what the minimum or maximum value is. It is going to change if it's negative. Now it's going to be opening down, so it's going to change it from a minimum to a maximum. It doesn't move it left or right, so it doesn't change the axis of symmetry. And then what is the description of the transformation? It is a reflection in or about the x-axis. In the second case, if I have a coefficient of 2, my a value is 2, my equation is y is equal to 2x squared. It's not going to change the vertex. It is not negative, so it's still going to be a minimum of 0. I'm still going to have the axis symmetry at x equals 0, and the only thing that I've actually done is a vertical stretch by a factor of 2. In the last case, if my a value is negative 1/3, then this would be y is equal to negative 1/3 x squared. My vertex stays the same. Because it's negative, my minimum becomes a maximum of 0. Axis symmetry is at x equals 0. And I would say first that this actually has two transformations. The first one is a reflection in the x-axis, and the second transformation is a vertical stretch by a factor of 1/3. I don't need to say negative 1/3 because I took care of that when I stated that there was a reflection. Now you can use those skills to try these ones and figure out what would the equation actually be depending on what changed with the p value, with the q value, and with the a value from what we've already covered.